Good day. In this video, we will talk about non-isolated systems when dealing with energy. Previously, we discussed how there are different types of energy: kinetic, potential, and this one can be elastic or gravitational. But those are not the only possibilities. You can have nuclear, chemical, aeolic, the one related with tides, with wind. You can have tidal, geothermal, hydro, acoustic, the one related to sound. Did I say thermal? I don't think so. Just thermal in general. Geothermal is the thermal energy that comes from the earth. And I could keep going, but this gives you an idea. Well, did I write electrical? This is a very important one, right? So some of them are the same thing. For instance, if you say solar is pretty much nuclear. Aeolic, well, is the wind moving, so it's kinetic. Geothermal, thermal, acoustic, it's still mechanical. This is another category of energies. So you have many and possible energies, and as we discussed before, you cannot create nor destroy energy. You can only transfer from one type to another. You transform from one type to another. In the video the other day, we talked about the gasoline and all that, but let me give you another example. And I'm gonna run it in reverse. If you lift a suitcase from the floor, or you are giving this thing potential energy, gravitational potential energy. But that potential energy came from where? Well, it came from your arm, right? And your arm, its chemical energy stored in the food. First, you had to eat something to get that chemical energy, right? And then it's stored in your arm, and ATP and everything, and then that's what gives your arm mechanical energy to bring this thing up. But the chemical energy in the food, well, of course, this comes from a plant, but you will know this comes from photosynthesis. Photosynthesis, that basically comes from light. But this light comes from the sun. And the energy that the sun sends us comes from nuclear reactions. So because nuclear reactions, the sun emits light, and through photosynthesis, the plant stores energy chemically that then through food you process, and that makes your muscles able to lift the suitcase. So a long chain of transformations of energy. In previous videos, we discussed what can happen to a system, right, that is acted by the environment through a force. So we said that if a force acts on the system, it can do work. Well, the system we were discussing then is what we call a non-isolated system. And work is not the only way in which the environment can interact with the system. Before we see all the possible ways in which work can interact with the system, I want to discuss the types of energy the system can possess. If the system, the one molecule or many molecules or one object or many objects inside these particles, let's say inside the system move, if the particles move, one or many, then you will have kinetic energy. As we discussed earlier, if the configuration of the system moves, then you can have also potential energy, especially when the configuration acts, the change in configuration involves conservative forces. And if that's the case, then you can have potential gravitational energy, you can have elastic energy. This is when you're dealing with against a gravitational system, or here when you have ideal spring forces inside. And then there is another type of energy that can live within the boundaries of the system, and that's called internal energy. And the definition of internal energy is actually the kinetic, which could be translational, rotational, or vibrational of the molecules of the system. Right, so if you have, let's say, a glass of water and the molecules are oscillating like crazy, then what we say is that this is very hot. We measure with temperature the amount of internal energy. That's what temperature is, a measurement of the internal energy of a substance. Okay, so these three, kinetic, potential, and internal energy, belong to the system, and we can change this if the environment can change this, interacting through the boundary, which makes the system non-isolated. So here's my system, and we know that the system then can possess kinetic energy if it's moving, potential energy, and internal energy. So one possibility is for the system to be interacting with the environment by means of work. Work that can be positive or negative. The environment, which is outside, can do positive work or negative work. Remember that we say that energy is like money. So you give money to the system, remove money from the system, let's say the bank, or your bank account. So work is one way in which you could do that. Let's say work could be like an Interac transfer, but it's not the only way in the bank by which you can take money. You can do a deposit, you could do a transfer between accounts, right? So in nature, there are also other possibilities for the environment to interact to the system. Another possibility is heat, in or out, right? When the system is very warm, it radiates infrared light, and that's energy, and that's not free, right? When there's very warm, when there's very cold, we have radiators in our house, and the radiator, of course, radiates heat, which warms the environment. But you could say the radiators in the environment, and you are the system, so the radiator interacts with you through heat. Another possibility is mechanical waves. A good example of this could be sound or an earthquake. Right? An earthquake can be so violent that it destroys the system because of all the energy it gives. Another possibility would be matter transfer. So, for instance, in or out, when you put gasoline in your car, you are putting gasoline in your car. The car boundaries is being crossed by the fluid, And that actually gives energy to your car in the form of chemical energy stored in the matter. You can have electrical transmission or electricity, let's say. We're very familiar with this one. We plug our systems into the wall to get electricity from the network. A last possibility could be, in general, electromagnetic radiation. Electromagnetic radiation, which is pretty much light, right? That can go in or out. Infrared radiation, in the case of infrared radiation, it's this and heat as well. But there are other mechanisms for heat, which we can discuss in class. And also electromagnetic radiation is not only the infrared light that hits you in the winter. Now, if you want to change the energy in the system, to change the energy of the system, you need transfer of energy, right? You need energy crossing the boundary. We need to add all the possible transfers, T. The T is for transfer, T, transfer. So this equation can be written as this. I'm going to raise this to make a little bit of room. So the internal system, all the energy that belongs to the system can be kinetic. So you can change the kinetic energy, or you can change the potential energy, and this one includes elastic, gravitational, electric. You can change the internal energy. So in order to change any of these or all of these, you need something, energy, to transfer the boundary. So this could be through work. This is work. Heat, we use letter Q. This, the book calls it transfer of mechanical waves. So T, mechanical waves. This, the book calls it transfer of matter. Or actually transfer of mass transfer. I want to put it the same way the book does. It could be electricity, right? Electrical transmission, ET. Transmission, electrical transmission. Or it could be electromagnetic radiation, with the book calls TER. And this is the general expression for all the possibilities you can have in a non-isolated system. Let's do the example of a TV. What the book tells us is that to define, I've copied this from the book, to define the system. So the system is going to be the TV. So I have my boundary here, and then I identify initial final configurations. It's not going to change the initial and final configurations in terms of position or positions of springs. Oh yeah, we have to identify the beginning and end of the time interval, so while we watch TV. But the most important part is to use this equation. So when the TV is operating, its kinetic energy doesn't change, nor does the potential energy, but it warms up. There is no force done on the TV, but it heats up. So there is heat leaving the system. There is electromagnetic radiation. You see the thing, there is light coming out. There is electrical transmission, the electricity goes in. There is no mass transfer, but there is mechanical waves, which is the sound. So the equation will be just the terms I put with a check mark. And that will be the equation that applies to the TV. In class, we will do other examples to practice how to use this equation.